let's look at the periodic table quickly. Okay, now there are two rules here. The what would I say, two columns, or would I say rows and columns? Because I can't see rows. But row is different from columns. When we're talking about row, okay, the row is just assuming the periods. Okay, those ones that are placed horizontally are periods. These ones are rows, and we have column. The column is assuming the vertical position, which is called the what? The groups. As you can see, you have the, from the screen, you have the group, and you have the what? The period. Okay, the period are the rows. We are asked in an exam, how many rows are there in the periodic table? How many rows are there? It's same as saying, how many periods are there in the periodic table? How many periods do we have there? 7 periods. We have 7 periods. And then in the long periodic table, this is a typical example of a long periodic table. It's not just a periodic table that just had a first 20 or first 30 elements. This is a periodic table that are having both A and B in one table. Group A and group B. I'm going to be classifying this periodic table. I'm going to sub-classify it in as much as this is the class of the arrangement of elements. But for easy understanding, we're going to still sub-classify it again, bring it down, so that we can have these two groups, how we are fixed in this table. That is the group A's and the what? The group B's. So look at this table. It's both group A and group B. Okay, now see that there's an interjection between group 2, that's after group 1, group 2, and group 13. Okay, this is what it is. But if that particular transition or the block element appears not to be in that particular group, that means you're going to have how many columns, how many groups? It's going to be just 8 groups. That is with inclusion of group what? Group 0, which we call group 8. That is without the transition elements, where you see them starting from after cows, you will see scandium and then zinc go down. Okay, without these elements that interject in the table in between group 2 and group 3, now what we refer to as group 13, because those ones starting from scandium, they are their own group. You can start them with group 1, okay, or you can now refer to them as group 1B. Let me give you an instance. Just looking at this table now, I'm just giving you a model of what we are looking at now. I have group 1 and 2 here. This is group 1 and 2, okay, and somehow it appears that group 1 is having more extra elements in it, just one more extra element, which is what? Hydrogen. Hydrogen is not supposed to be placed here, but maybe I'm still going to explain that at the course of the class. So we have another column here. This is column. Another column, another column. Okay, so this is column, but anything that goes in the column like this is row. Are you with me now? So this is row. Each of these are what? Column. Okay, now I have hydrogen here. Next element that will be here will be what? Lithium, followed by sodium and a what? Potassium. Are you there? By extension, I have next element after potassium is rubidium, and then I have cesium, and then finally is what? Francium. Are you there? So giving you how many columns here? 7. I mean, how many rows? 7, which is 1, 2, 3, 4, 5, 6, and the what? 7. That means apart from hydrogen, all the elements placed here, from lithium to to frank all have the same chemical properties. Okay, so as you're arranging, you now look at this now. Let's place the atomic numbers. Now. Atomic number of hydrogen is 1. Atomic number of lithium is 3. This is 11. This is 19. This is 37. This is 55. And this is 87. Atomic number here varies. But why they are placed in this particular group, why they are occurring here, is because they appear to have the same words property, the same chemical what property. You can even say they have the same physical property because all of them are what solids, or all of them are what metals, with the exception of what hydrogen. So sometimes you see, sometimes hydrogen is placed in between the periodic table without being here for the sake of convenience. That is why we are allowing it to be here. And if you go to group 2, you have the likes of beryllium, magnesium, calcium, you have strontium there, you have barium, you have radon there. So atomic number here is 4, 5, sorry, 4, 12, 20, 38, 54, and what? 56. Okay, it should be increasing. 56, and then what? 80 what? 88. This one is group 1. Each of elements in this column are group in this column. But if you're going through this column, it is what? It is what? Period. Or row. Or what? Rows. Then this is going, let's call this group 1. And this what? Group what? 2. It should be in Roman figure. That's the best for assigning groups. It should be in Roman figure. This can be in Roman numerals. This is the best to do it. So, as in for African students, but for international students, this is very okay. Whichever number, so far is a number. But for we're using what? Roman numerals. For what? Groups, or numerical for period. Okay, before we continue the group, then somewhere here, there's another group here. Just let me not add the two together. It starts here and end here. Okay. There are about 10 groups. 10 groups. Okay. About 10 groups. Now, these 10 groups that are here, let's see if we can have up to 10 groups here. 1, 2, 3, 4, 5, 6, 7, 8, 9, okay, 10. So we have just 4 periods. 1, but it starts from period what? 3. Next, period 5. Next, period 6. And then what? Period what? 7. Okay. And so, we will continue here. This is going to be what? Group what? 1 again. It's on its own. But from what you are seeing on the screen here, you are seeing group 3, isn't it? Okay. But this is how it's supposed to be. But you can see this method appears to be much like old method of periodicity. But this is what I have it. But this is now, we will now have A and B now. This one we have here, first group 1, we're going to call it what? Group what? 1A. This is going to be what? Group what? 2 what? A. Then this group 1, so in order not to conflict this one and this one, this will now be what? Group what? 1B. This will now be what? Group what? Group what? Okay, sorry. That would have been, let's continue the number 1, 2, then this will be group 3. You don't do that like that. There's a irregularity in this table. Instead of this group 1 here, Here is what we have group 1A, and here group what? 2A. That's the irregularity. This is group 3, but it is what? Group 3B. All these elements here are B, don't mind me. This is B. So here will be what? Group 4 what? B. Group 5 B. 6 is it 5 B? Yes. Group 6 what? B. 7 what? B. 8 what? B. And 9 B. And then what? 10 B. And then 1 B. It can't have more than 10 in this group. So that's why this become 1 and 2. This irregular anomaly. This 1 and 2 supposed to have started from here was an anomaly. We're going to explain that via the electronic configuration of the element that will be in that column. Okay. So the first element that is in this particular group is what? Scandium. The last is what? Zinc. With atomic number, after 20, you have 21 here, and here will just be what? 30. Are you with me now? Then we continue. We can continue our group. So that's where we continue. Continue here. This is where we continue. Are you with me? And then there will be last one somewhere here, and then on top of it, as you have your life of what? Helium. In the same period with this. Okay? The another one will be here, and this, and what? This. So this will be what? Which group will be this column? This is what? Group correct. Group what? 3 what? 3 what? 3A. Then 3A, let's put it here. Group 3A. And here will be what? Group 4A. 5 what? A. 6 what? A. And then what? 7 what? A. And then what will be here? 8A. I mean, 8 what? Nothing like 0. More like group 8. Or group 18. So, but if I'm using, what do you call it? The system we have on the screen, then we have to name everything the way it is in the row. So this will be 1, just like what we have here. Stop here. So this will be what? 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This one now what? 13, 14, 15, 16, 17, and what? 18. Are you with me? Okay. So that is, so you now see that you are arranging periodically using the order is what? Increasing. By the time one electron enters it from atomic number 1, you arranged, and then here is what? 2, here is 3, 4. Element here is what? 5, 6, 7. Here is what? 8. Here is what? 9. And here is what? 10. Now you start again to arrange. Once you reach here, you come back. As you are arranging, these properties are now reoccurring. Do you understand me now? You suppose that if you arrange, it reoccur. It's not as if you are, after arranging, by the time you are getting here, you are having kind of a non-metal here by mistake. It's not happening here. So as this thing is being arranged like this, even when you get to this point, you now see that there's inner block inside here, because this is not where it's going to end. Okay, we're still going to go inside here and break it in and bring that way have the latinite and what? Actinite. Are you there? So you now see that as you're going, the property is what? Reoccurring. So that's why we are arranging or classifying this element in order of increasing what? Atomic what? Numbers or electronic configuration.